Okay, so first thing I want you to do is have your formula sheet out as we're working through this, and I want you to locate the angle addition laws, and I want to explain kind of how they're condensed, but because they're condensed, we need to know how to read that formula. So for example, you have one, and I'm not sure, are they using V and U? So it says, let's see here, where are they? It says sum and difference formulas. It's on the left side towards the bottom. And the first one you see is that the sine of u plus or minus v is equal to the sine of u cosine of v plus or minus sine of v cosine of u. Is this the format that you have? You guys see that? Okay. So really this is two formulas built into one. Sometimes you want the sum formula. Like if I want just the sine of u plus v, then I'm going to work with the sine of u times the cosine of v. Do I use the plus sign or the minus sign? Okay, and that's the way these work. So if the top one's plus, you're going to use the top one as plus. Now look at the cosine. The top one's a plus sign, but what's over here? You see the minus sign? So you need to be careful to use the right sign. So this would be the plus sign. Right, and if I wanted the sine of u minus v, okay, so I just want you to be able to understand what you have in your formula sheet is really these two formulas condensed. And so, what's that? U and v are the two different angles. Yes. Okay. Thank you. And we're gonna use these formulas, and you'll start to see what U and V are. But I just want to explain that these are condensed into multiple formulas. Okay. So our first example here, I want us to simplify using these angle addition laws, and we have the sine of 310 times the cosine of 55 minus the cosine of 310 times the sine of 55. And so you can think of 310 as your u and 55 as the v. And then you're going to kind of look at your formula sheet and say, well, which one would this apply to? Is this equal to the sine, the cosine, or the tangent? And if it, once you find it, is it the sum or is it the difference? And so look at your formula sheets and see which one you would use. What are we going with? So this is one where the product is sine cosine, right? If you look at the cosine law, you don't have that. You have cosine and you have sine and sine, right? So you know it's not the cosine. It's going to be the sine. Is it the sum or the difference? Difference, because we got the minus sign here. So you're going to have to look at that pattern and recognize which one to use. So this is really the sine of u minus v, which would be 310 minus 55. It's simplified down to this. It's this formula right here. Okay, I gave you the right half. You're putting in the left half. And so now we can find out, well, what is 310 minus 55? You could do that. Yes. So u is one angle and v is the other one. No, I mean it can swap, like sine of u cosine of v is the same thing as cosine of v sine u. So you can swap them, and it's actually, so I have uv vu over here, right? But over here I have uv and uv, so it's the same it's the same thing because your product, you have the commutative property where you can move things around. Yes, it would be different. Oh, so you're saying, well, like which one? How do you know what's U and how do you know what's V? Okay. Well, let me ask you this. What is the sine? First, what's the sine of negative theta? Negative sine theta, right? Okay. And so it's going to matter by a negative sign. And so it does matter which way we're going to go. If we went 55 minus 310 or 310 minus 55. And so here's how you tell. It starts with sine. Well, the U goes with sine here, and you don't have the sign here with the V. And so whatever sine's with in that first term, that's your U. And whatever cosine's with in that first term is the V. And so you're going to have to go 310 minus 55. If I had sine of 55 first, it doesn't matter the order here, but it's whatever sine's with is your U, whatever cosine's with is your V in that first term. Yeah. Yes. Okay. No, these are good questions, and these are the things, the details that we need to work through. So we have to go 310 minus 55. You don't want to go 55 minus 310. In some forms. So cosine, it doesn't matter. Because what is the cosine? What's the cosine of negative theta? Cosine of theta. So it doesn't, when you get to cosine, it doesn't matter what U and V are. You're going to get the same answer. But it does matter what sine is. And we'll get to that. We're going to practice these. But let's continue with this problem. What's 310 minus 55? 255. All right. And is that what I want it to be? Let's see here. I think so. No, I made this, and I'm hoping this will work out here. So so we know how to find the sine of certain angles and cosine of certain angles already. And this is going to take us back to the unit circle. So on the unit circle, like 0, 30, if we count by 30s, we know how to find the sine of all those angles. So 30, 60. I'm just going to list a few out here. Get close to 255. Okay, and then in between there, we also have 45s, right? We know the 45, 90, 135, 180, 225. Okay, and so is there a way to use these numbers to make 255 by adding or subtracting? 225 plus 30. So this is the sine of 225 plus 30, because we're going to want to figure out what is this equal to? What is the sine of 255? And that we can't find based on what we know already. So we're trying to relate to something that we can find from the unit circle that we studied last unit. And those are the angles that we can work with, and we can continue that list. But those are the angles. And so 225 plus 30 is our 255, and I'm splitting that up. So now I'm going to go back to my formula. And I'm going to use the sum formula again. And so this would be the sine of 225 times the cosine of 30 degrees. Do I use a plus sign or a minus sign? Plus. Okay. And then the sine of, I use the opposite angle this time, 30 degrees times the cosine of 225. Okay. And at this point, we know these values, or hopefully you remember how to find these values in the unit circle. And you can use a little picture to help you. So 225 is in which quadrant? The third quadrant here. And that creates a reference angle of 45 degrees, right? And if the hypotenuse is 1, we have negative root 2 over 2 and negative root 2 over 2 for the x and y values. And so the sine of 225 is what? Negative root 2 over 2. Cosine of 30, you guys remember? Root 3 over 2. Sine of 30, 1/2. And the cosine of 225? Negative root 2 over 2. So now we're approaching an answer here. So now I can multiply these fractions together. What's negative root 2 over 2 times root 3 over 2? Negative root 6 over 4. And then plus, I'm going to end up with a negative root 2 over 4. And so now I'm going to make one fraction over 4. So negative root 6 minus root 2 all over 4. And that's our answer. Or you could factor out the negative and it will look like this. Root 6 plus root 2 all over 4. Okay. So this is the kind of work we're going to do with these formulas. Right? We're going to get something that we don't know, like I don't know the sine of 310 or the cosine of 55. But I can use these formulas to get it to something that we do know, 225 and 30, and work with that. Simplify this. This is as far as we can go. How did I add these together? When you add fractions, if the denominator is the same, it stays the same. And you just negative over here. Yeah, I multiplied. Okay. So we're going to try this again with example 2. 1 plus the tangent of 25 degrees times the tangent of 100 degrees all over the tangent of 25 degrees minus the tangent of 100 degrees. Okay? And so the first thing you're going to do is start looking at your formulas and trying to figure out where to go from there. Okay? And I'm going to pause and let you write this down, and let's give you a moment to look at your formulas. So I'm going to copy the formula so we can compare here. The tangent of u plus v, or u plus or minus v is what you have, right, is equal to the tangent of u plus or minus the tangent of v all over 1 minus plus, is that what you have? Tangent u, tangent v. This is what you have on your paper, right? Or no? Do you not see this on your sheet? You got to locate that. So this is the one we're going to use, but how does it match up with this? This looks upside down, doesn't it? And it is upside down. So it is a cotangent. But here's how you change it around. If you put this, if I want to flip this fraction over, like if I had x, x is the same thing as 1 over what? One over x, right? If you flip this over and put it under 1, and that's what I'm going to do here. I'm going to say this is 1 over the tangent. Cotangent is 1 over tangent, is what I'm saying. right? And this is the cotangent form, and I want the tangent form. So this is the tangent. I'm going to flip the fraction over. 25 minus tangent 100 over 1 plus tangent 25 tangent 100. Okay, and now we can compare this with the formula we're having. Okay, you see it? So I flipped it over. It's just like saying that cotangent is what you guys are seeing. It's upside down. It's going to be 1 over the tangent, and that's what I'm doing. I'm putting 1 over the tangent form. Okay, just to relate that to you here. So is this tangent of u plus v or tangent of u minus v? Okay, and what's u? 25. Okay, so this is the same thing as 1 over the tangent of 25 minus 100. Now it's looking a little bit easier to work with, which is 1 over the tangent of negative 75 degrees. Okay. So at that point, we don't know how to find the tangent of 25. We don't know how to find the tangent of 100. We don't know how to find the tangent of 75. And so now we got to go to those numbers that we do know how to work with. And if you count by 30 and you count by 45, you can generate a list of those numbers. What's that? 45 plus 30 works. And there's other ways to do that too, but that works. But we have to make a negative 75. So you could do 1 over tangent of negative 45 plus a negative 30. Is that what you mean? Okay. And so try to finish that. So you're going to plug that back into the formula, and you're going to actually find those values and simplify that. There's a lot of details in that work. I'm going to pause there again. Try to plug that into the formula that you have on your cheat sheet and work through that. Yep. The tangent of 45 plus the tangent of negative 30 is not equal to the tangent of negative 5 plus the tangent of negative 30. Okay? It's equal to, that's why we have that formula, to see what is this equal to. That's what we're using the formula for. So your next step, when you use that formula, it's going to look like this. 1 over, and now I'm going to plug this into the formula, so I write tangent of negative 45 plus the tangent is plus because there's a plus sign here. Oh, I just put a negative sign under there. But yes, it's a plus sign. So you're following the formula. Let me finish and then we'll talk about that because I think it might clear up once you see the rest of this. Over 1 minus the tangent of negative 45 tangent of negative 30. And now I'm going to compare it to the formula. Let's see here. So I'm using the tangent u plus v. And so I want the tangent of u plus the tangent of v. And that's what I put here, the tangent of u plus the tangent of v. And I want it over 1 minus the tangent of u, tangent of v. And that's what I did here, 1 minus the tangent of u, the tangent of v. The very original. Oh, did I lose track of that? No, okay, here it is negative, yes. But then we made negative 75. Okay, so yes, this first one we used the negative one. And then we were done with the formula when we got here. And then we used the formula a second time, and now we're going to use the positive one because yes, we're using a second formula because the way we split this up was a sum, and now we're using the sum formula. So yes, you're right. We started with this is the form of the negative, the u minus v, and that's why we put it as u minus v here. And this is the sum formula. Not every time. It's whatever you need. Okay? Now, once you're here, now you start plugging in, finding these values, like we did last unit, using the unit circle, and trying to work through this. And remember, you got to simplify it down to one fraction. You don't want fractions inside of fractions, and you don't want radicals in the denominator. So see, keep going. I'll pause there. So at this point, we're done with the formula. We're now using the unit circle to find out what is the tangent of negative 45 and what is the tangent of negative 30. And I'm going to make the assumption that you know how to do this right now. And if you don't, pull me aside and we'll go over how to do this. But what did you get for the tangent of negative 45? Negative 1. And the tangent of negative 30, negative root 3 over 3. Okay, that's what you want to get for those. So now I start to plug those in. And if you want, we don't need to leave this as a fraction or a fraction. We could flip this back over, right? So let me flip it over. So I get 1 minus tangent negative 45 tangent negative 30. So now is not the time to talk. Okay. Over tangent negative 45 plus the tangent of negative 30. And then I'm going to, so all I did is I flipped this fraction over to get it out of this complex fraction. And now I'm going to substitute in tangent negative 45 and tangent negative 30. And I get 1 minus negative 1 times negative root 3 over 3 in the top part of the fraction. And negative 1 plus a negative root 3 over 3. So all I've done is substitute in those places. And now it's just being very careful not to confuse the negative signs because that could throw you off. Why did what? No, you can leave it. I just didn't want to deal with a fraction and a fraction. So I was trying to make it easier to work with. Okay. So now we have 1 minus root 3 over 3 and negative 1 minus root 3 over 3. Okay. So for each of these, I gotta change each of these into one fraction, right? So I'm going to change the 1 to 3 over 3 so I can make one fraction in the numerator. I'm going to change the negative 1 to negative 3 over 3 to make one fraction in the denominator. And I end up with 3 minus root 3 over 3 in the numerator and negative 3 minus root 3 over 3 in the denominator. Because this is 1 over 1, and I multiplied top and bottom by 3. And this is negative 1 over 1, so I multiplied top and bottom by 3. Where? Right here? Up here? So it's 1 right there, you're thinking? These? That's going to be positive, yes. but I still have a minus sign there. So it's 1 minus a positive number, and that's why I have 1 minus a positive root 3 over 3. Okay. At this point, I'm going to reduce the fraction. I'm going to multiply top and bottom by 3 to get rid of the 3. And now I have 3 minus root 3 over negative 3 minus root 3. Okay. And so I can't have a radical in the denominator. So this is where the conjugate helps. So I'm going to multiply top and bottom by the conjugate of the denominator. And the conjugate would be what? Negative 3 plus root 3. And so I'm going to distribute. And when you distribute the conjugates, what happens is you're only going to need 2 terms. The middle terms will always cancel out. That's why we multiply by the conjugates. So in the numerator, we're going to have negative 9. So 3 times negative 3. 3 times root 3 is 3 root 3. Negative root 3 times negative 3 is still going to be a positive 3 root 3. And then negative root 3 times positive root 3 is going to be a negative 3. In the denominator, we're going to have negative 3 times negative 3, which is positive 9, minus root 3 times root 3 is 3. Now we're almost there. We're getting really... Negative 9 and negative 3 is negative 12. Plus 6 root 3 all over 6. And that's negative 2 plus root 3. That's the final answer. Okay. There's lots of fraction work to be careful with here. Okay. Well, we got this week. We got today and tomorrow if we need. I mean Friday. Yeah, you got tomorrow too. You know, you won't see me, but you got tomorrow to work on it and think about it. Okay. All right, I got one more example to go over with you. Okay. So these problems right here are going to be like, you guys have your homework in front of you? These are going to be like numbers 6 through 10. Okay, that's what these are going to be like. And 6 through 10, by the way, I'm going to, don't start on them yet because I'm going to give you different numbers on them. Okay. All right. What I want to do now is to give an example of something like numbers 3, 4, and 5. Okay. So that's this third example is going to be to help you with 3, 4, and 5. So here we're asked to evaluate the exact value for sine, cosine, and tangent using the sum and difference formulas. And then check that tangent theta is sine over cosine. And we have theta is negative 105. And so we're going to kind of do the same thing we were working at before. Do we know how to find the sine, cosine, tangent directly of 105? Is 105 one of the angles that we've studied? No. So the first thing we got to do is work off of our list. Is there a way to use the numbers we know to create a 105? Negative 6. So this is negative 60 plus negative 45. No. Or we could use, okay, negative 60 minus positive 45. Okay, the difference is, so you can use, in this formula, I'd use the difference formula. Here I'd use the sum formula. And there's actually other things that we can come up with. Come up with one more that would work. Don't use 60 and 45. Make 105 with something else that we know. With something else that we know how to work with. What's that? So negative 150 plus 45? That would work. So and there's actually probably hundreds of different ways to make it with something that we know. Okay? So you just find something that you want to work with and you work with it. Which you want to use the sum or you want to use the difference? Sum. Okay. So you're going to do this. You're going to find the sine, first of all, and you want to show your steps and show your work. So we're going to write the sine of negative 105. And then you're going to write the sine, and you're going to split up that negative 105 how you want. And we chose negative 60 plus negative 45. And then you're going to, this is when you have to use your formula that's on the cheat sheet that you have. Okay? And so you got to use that formula correctly. And so what would I write? Sine of negative 60 times the cosine of negative 45 plus or minus? Plus. And then I'm going to flop them, right? So I'm going to find the sine of negative 45 and the cosine of negative 60. Okay. So if I draw my quadrants, for negative 45, that would be in quadrant 4. So the cosine would be positive root 2 over 2. The sine would be negative root 2 over 2. So right beneath the cosine of negative 45, that's going to be positive root 2 over 2. Beneath the cosine, or sorry, the sine, that's going to be my negative root 2 over 2. And now I need to find the sine and the cosine of negative 60. So I'm going to draw another picture to help me. $60 here, 1 here. This is root 3 over 2, but it's negative. And this is 1/2. So the sine would be negative root 3 over 2. And the cosine would be positive 1/2. And so then I need to multiply my fractions together and get negative root 6 over 4. And then multiply those, and I get negative root 2 over 4. Denominator is 4, so make it one fraction. Negative root 6 minus root 2 over 4. And you guys have seen this before, right? Okay. So try this with the cosine, because we're not done. We got to find the sine, the cosine, and the tangent. So now I want you to find the cosine of negative 105 using the formula. Use the same angles. Yes. So go ahead and find the cosine of negative 105. Similar way as we did with sine. You're going to write cosine of negative 105 is equal to the cosine of negative 60 plus negative 45. But this time, the next step's going to be different because you're going to use a different formula. You got to use the cosine formula in your packet to plug in. This is my u, and this is my v, and I'm going to plug it into that formula. Okay, so the formula here It's cosine of negative 60 times the cosine of negative 45. This is a different formula now, right? Do I use a plus sign or a minus sign for the formula? It's a sum here, so you actually put a minus sign here in the formula, right? And you're going to use sine of negative 60 and the sine of negative 45. And we found the sine of 60 and the cosine of 60. We did this already in the previous part, so we don't have to do it again, which is nice. We just need to use them and plug them in. So cosine of negative 60 was what? Positive or negative? Positive 1/2. Cosine of negative 45 minus and negative root 2 over 2. And then once you're there, you're almost done. It's almost the same, not quite. It's answer is going to be root 2 minus root 6 all over 4. If you look at it's the formula. If you look at your formula, you see how you have a plus minus here? And then over here you have a minus plus. You have to follow that's why I'm saying be careful to follow what the formula is saying, because they put them both together. Okay. All right, one more time, find the tangent of negative 105. On this one, we're going to use the formula, and then after that, we're going to do your method, sine over cosine, and see if they match up as a check. Okay, so use the formula first, and then we'll do the other one. So we already found the tangent of negative, or no, we didn't find the tangent of negative 60. We got to find that, huh? And so we can go back to our picture or however we want to do that. But tangent is sine over cosine, and so the tangent would be negative root 3 over 2 divided by negative 1/2 or positive 1/2. And so what's the tangent of negative 60 going to be? Negative root 3. And then tangent of 45 is 1, so tangent negative 45 is going to end up being negative 1. And so those are the values we're going to use. And so we end up with, let's see, negative root 3 minus 1 over 1 minus negative root 3 times negative 1. And simplifying that a little further, you get negative root 3 minus 1 over 1 minus positive root 3. Negative times negative. This times this is positive, and you got a minus sign there. Multiply by the conjugate, which is 1 plus root 3. And, well, I'll just multiply this out. So you get negative root 3, negative 3, negative 1, negative root 3. And when you multiply conjugates, all you need is the first times the first, and the last times the last. And I get negative 4 minus 2 root 3 over negative 2. Negative 4 divided by negative 2 is positive 2. Negative 2 divided by negative 2 is positive 1. Root 3. Positive 2 plus root 3. Okay. Question? Oh, good. Good. Now, One more thing, we're not done with this problem. If you look at the instructions, it said one more thing, and take a look. It said evaluate sine, cosine, tangent. We did that. Now we're going to check that our answer for tangent is our answer for sine divided by our answer for cosine. Okay, so last part here, we have our answers. Let me grab them. So my answer for sine was negative root 6 minus root 2 over 4. Divide that by my answer from cosine. And if I simplify that, I should get my answer, I should get 2 plus root 3. And if you haven't done that yet, I want you to do that. If you have done that already, you could work on the homework. I want you to do it both ways. I want you to use the tangent formula. And then this is going to be a check for us that if we get this right, that means we've done all three of these right. So this is going to be a check for us. You don't know how to solve that? Yeah. So first step, reduce. All right. Next step, conjugate. And distribute and see if you can make it look like the answer for tangent. I'll be right there, Megan.